ladies and gentlemen.
So let's talk direct and inverse proportionality. To start off, two things are directly proportional if when one grows, the other grows as well, or if one shrinks or decays, the other one shrinks and decays as well. They move in the same direction, if you will. So how that's represented analytically would be using this equation of y equals some k times x, where that k is the proportionality, the amount one changes in accordance to the other. If they have a one-to-one relationship, meaning if I add one to one and I add one to the other, then that k would be 1. But if I had a 1-to-2 relationship, then the k could be 2 or 1/2, depending on which variable is representing what. The opposite of that would be inversely proportional. So two values are inversely proportional if when one grows, the other one decays or shrinks, or vice versa, as one shrinks, the other one grows. So they move in opposite directions of each other. That same kind of value, what's determining that relationship, whether it's one doubles as the other one shrinks by 1/2, or so on and so forth, that's your k value, that relationship between the amount moving in either direction. So let's play with this. Question 1 asks us if x and y are directly proportional and x equals 10 when y equals 8, what is the value of x when y is 10? So first and foremost, if I look at what the question's asking me, it wants the value of x. So I'm going to set up my equation so that the x is alone. So x is equal to some k times y. To figure out what that k is, we have some reference value. We have when x is 10, y is 8. So we can find out k for this relationship. So using this setup, we have 10 is equal to k times, not y, in this case it would be 8. So to solve for the k, we can divide both sides by 8. And in doing so, we get k is equal to 10/8, which is reducible. Both of those are even, so we can reduce it by a factor of 2 to get us 5/2. So over here, we can replace the k with 5/2. And the y, we already know we want that to be 10 in this instance. So we're going to replace the y with a 10. So we have x is equal to 5/2 times 10. And in order to do this, you could do multiple different things. I'm going to multiply 5 times 10. That would be 50. And then half of that would be 25. So x is equal to 25 when y is equal to 10. Not too bad. What about inversely proportional relationships? So we have the same setup. In fact, everything is exactly the same except for directly and inversely. Well, like before, since we're finding the value of x, we are going to set x equal to, we're going to have that alone, isolated on one side, but instead of k times y, we're going to have k divided by y. Same idea, I can plug in my value known, the relationship known, to find the k. I'll do that over here on the left. We have 10 is equal to some k over 8. We can get the k alone. We can isolate it by multiplying by 8 instead of dividing this time. So we have 80 is equal to k. So with this and the situation we want specifically is when y is 10, we can set up x is equal to 80 divided by 10. 80 divided by 10, x would have to be 8 in this case. So really not too bad, but it's formulas, and formulas can always be iffy. It requires memorization. So I want you to think of when two things are directly proportional, they grow together. When things are inversely proportional, they go in opposite directions. So as one gets larger, the other one gets smaller. And since the y got larger, the x had to get smaller. So if it gets larger as well, that tells you there's a little bit of a problem. The last thing that you might be asked is, instead of a directly proportional relationship between the two variables themselves, it could be a directly proportional or inversely proportional relationship between some modification of these variables. So in this case here, we have x by default, but we have the cube of y. So that means in our relationship where x is equal to k times y, or y is equal to k times x, the y is going to be cubed in either case. Since we're trying to find the value of x, the x we're going to isolate, so x is equal to k times, instead of y, y cubed. So, not too bad. Same idea though. They give us some initial value to start to look for k, and then once we have that k, we can plug in the 2 for y and we'll get our x. So, using our initial values, we have 9 is equal to some k times, not y in this case, 1 cubed. 1 cubed is 1, so 1 times k is k. K is 9. So using k of 9 and y of 2, x is equal to 9 times 2 cubed. 2 cubed is 8, so this is 9 times 8, which is 72. So the x would be 72. And as you can see, the y grew, the x grew, directly proportional. That makes sense. It grew by a lot, but do keep in mind that we were talking about the cube of y, which is going to make the relationship a little bit more drastic than it was before. If you have any questions about this, please let me know. Otherwise, I look forward to seeing you in the next video.